Yeah, good evening everyone. So we'll start structure of atom today. Okay. So now in this chapter, what we are going to study first? So we are going to understand how the particles are arranged in the atom and what are the early discoveries were led to the discovery of this. What are the early trials were led to discovery of this atom? Okay, we will discuss this. Okay, first thing is here. What exactly an atom word means? The word atom says. See, atom means it's a Greek word which means we cannot subdivide a particle. Like atom cannot be subdivided. So this is how the early consideration was taken. But later on what we got to know? So there are some subatomic particles present in the atom like electron, proton and neutron. Okay. So now like the discoveries, the early discoveries which were shown or proven that there are some subatomic particles like electron, proton, neutron. So who discovered the electron? J.J. Thomson. Okay. So then next proton, Goldstein. Okay, and neutron, Chadwick. Okay. So these are the particles discovered. We'll discuss how they got how they discovered these particles. Okay, like cathode ray tube experiment, anode ray tube experiment, those things. And you know, now next what we need to know, how these particles were arranged in the atom. This is also one more thing to be discussed right now, right? So now first of all, who are the notable scientists here we have? So J.J. Thomson. So we have J.J. Thomson atomic model, we are saying like plum pudding model, like watermelon model we will say. Okay, so this is the first model we have got. Okay, so before this what I am saying, we need to discuss about discovery of electron, proton and neutron. After that, how these subatomic particles were arranged in the atom. So first person is what? J.J. Thomson or plum pudding model we are saying. Then next we have Rutherford's atomic model, and then next we have Bohr's atomic model, and then next we will be moving to the other quantum approach. Okay, so like quantum theory we have. Okay, before that only we will study de Broglie wave equation and Heisenberg's Heisenberg principle, and at the last we need to discuss about quantum numbers also, like writing electronic configuration we need to know now. So for that we need to know quantum numbers. Okay, that is the important point. Okay, let us discuss about the early discoveries of this electron, proton and neutron first. Okay, so discovery of electron. So for this they have taken a tube. Okay, so in this tube, see, it is having two electrodes like two rods here and here, okay, that were connected to a battery. So for application of high voltage they are using some external energy source like battery here. Okay, so around some 10,000 volts they were supplying the electricity through this, and in this tube they are taking some gas. Okay, what they have taken? Some gas. And see, gases will move with very fast, right? Okay, so in order to decrease the acceleration or to decrease the velocity or the movement of particles, they are using something called vacuum pump here. Okay, why? To maintain very minimum pressure, so that if there is minimum pressure, particles will move very slowly right now. So it is easy to ionize by applying high voltage right now. So therefore whatever the gas you are going to take here, for example I am saying a gas G is taken here. Okay, if gas G is taken, what happens when we apply this high voltage to this? So this current will ionize this gas, yes or no? So now this gas is getting ionized. So ionization means whenever it is got ionized, so they have found that some positive charged species like G plus and some negatively charged species also released from that gas G, whatever the gas they are taking here. Okay, so now what he found that, see, battery, see, these electrodes will be having some negative charge and positive terminal, negative terminal now. Okay, so now some particles were moving positive, like this is positive charge, another one is negative charge particle coming from gas now. So now he found that there are some particles moving towards anode. So what this anode contains? It's a positive charge, like anode attracts anion. So negative charged particles are attracted towards anode. So it means he found that there are some certain particles which are attracted towards anode. So now how he got that some particles are going towards anode? See, he made some holes to this anode, like perforated anode we can say, and he applied some green or the fluorescent material here, zinc sulfide. Now what happens? This particle go and hit this surface by through the holes of this anode. Now what happens, there will be some glowness will be seen, that is called fluorescence. So by that he observed that there are some particles releasing from gas that are hitting the positive terminal of this electrode. It means definitely that particle should contain what charge?
Negative.
See, this terminal is positive. It means like charges won't go each other, na, like charges repulse. So opposite charges only goes, na. So some negative particles from the gas G is coming out that are hitting the positive terminal of this tube. Okay. Now he analyzed the same experiment. He repeated the same experiment by taking different gases. Let us say first of all I am taking hydrogen gas. Okay. I am taking oxygen gas and taking some different gases you take like this. Okay, or helium or any gas you take. So from all these gases you are going to get some cationic part. Okay, so something like H2 plus I am writing, electron I am writing here, O2 plus I am writing, electron I am writing here. See, whatever the gas you are going to take, the negative particle which is coming from the gases is same, yes or no? It means he observed by taking different gases here. So whatever the gas he is taking, the particles which is moving towards positive terminal is being same. What the properties of the electrons here, the negative charged particle is being same. It means the particles which are moving towards the anode terminal is considered as electron and they are having same properties like irrespective of gas you are taking in the tube. So whatever the gas you take in this tube, all of them are releasing
same cathode ray.
Same charged species like E minus that are electrons. Okay, now what I can say, so whatever the particles, the electrons here which are emitting from the gas are independent of gas taken in the tube. Okay, so now here you just see these points to be noted here. So cathode rays moves from cathode to anode. So anode means positive terminal, so it means the electrons are moving from cathode to anode. Will you agree with this statement? Yeah. So in the exam you can expect a question based like a statement based question from this particular topic. Okay. So cathode rays travel in a straight line, okay, with a high velocity, absence of electric and magnetic field. Okay. So cathode rays are more efficiently observed with the help of a fluorescent material, zinc sulfide. We have seen now like this, I told you perforated anode is there. It means like making holes on the anode and applying fluorescence material like ZNS where the electrons will hit this and show glowness, I told you here this side. Okay, next. Now cathode rays rotate the light pedal wheel placed in the path. For example, here what these beams are coming here, electron beam is coming now. So if I place a pedal here, what happens to this pedal? If I am placing a pedal here, so these electrons will come and hit this pedal now. So now what happens to the pedal? They will rotate. Yes or no? So by this what he is saying is, so the particles have like electrons have particle nature. What is that? Electrons have particle nature, shows the particles of cathode ray are particle material or material particles which have mass and velocity. It means that particles, that electrons are moving with some velocity and has some mass. Okay, so now one more thing, now what we need to know, what is the mass of electron, because he is saying the electrons have particle nature. It means it has some velocity, moving with some velocity and having some mass. Now what is the mass of electron, we need to know. Okay, so for this again he did one more experiment, we will be studying that. So look at here, so what he did is, the electron beam is coming from here, see this yellow color, green color or yellow color beam which you are seeing, this is electron beam. See, he applied perpendicular electric field and perpendicular magnetic field. In one case he applied electric field and in other case he applied magnetic field. He has observed some deflection. See, when he applied electric field, see the beam, this electron beam is moving towards or deflecting towards which side? Positive terminal of this electric field. Similarly, in the magnetic field also he observed the deflection like this. Okay, so now by careful measurement of the deflection, like careful balancing of this deflection in electric field and magnetic field, he found charge to mass ratio of electron, what is that? Charge to mass ratio of electron is around 1.75 into 10 power 11 coulomb per kg. What is the value he got? Charge to mass ratio of electron as 1.75 into 10 power 11 coulomb per kg. So this, see, more than the experiment, you should remember the values here. What is the mass to charge to mass ratio of electron, they will ask. What is that? 1.75 into 10 power 11 coulomb per kg. Okay, then next, what we got? Mass to charge to mass ratio. Next, I especially want what is the mass of electron here and charge of electron. So for this we have one more experiment called Millikan's oil drop experiment. Okay, so in Millikan oil drop experiment also, see, he used some oil drops and he passed some gas to this chamber. So where he made that whatever the gas particles sent here were got ionized. Ionized means they will also release electrons, no? So now all that electrons were accumulated on these oil drops. Okay, now oil drop got charged, yes or no? Because initially oil drop is neutral, but when this atom is sent into this and got ionized, ionized means that atom releases ions and electrons. Now all the electrons are like adjusted on the oil drop that is sent here. Okay, so finally what he got from this is the total charge present. The total charge present is equals to number of electrons. The total charge of oil drop is equals to Q I am writing, that is equals to number of electrons present into the charge of one electron. So Q means what? Total charge present on the oil drop is equals to number of electrons present on that oil drop into charge of one electron. Okay, the minimum charge, in this case the minimum charge present on the one oil drop, what I am saying, the minimum charge, in order to show minimum charge the number of electrons should be 1. So 1 into E right now. So the minimum charge present on the oil drop is found to be 1.602 into 10 power minus 19 coulomb. What is the minimum charge found on the oil drop? 1.602 into 10 power minus 19. Okay, so electrons now, so you use minus 1.602 into 10 power minus 19 coulombs. Okay, so initially in the previous case what we got? Charge to mass ratio, E by M or Q by M, that is how much I told you? 1.75 from J.J. Thomson experiment, 1.75 into 10 power 11 coulomb per kg. Okay, this value we have, and from Millikan oil drop experiment we got charge of one electron. What is the charge of one electron? 1.602 into 10 power minus 19 coulomb. So using these two values, can we find mass of electron or not?
Yes.
Yes. So what is the mass of electron now? See,
9.1 into 10 to the
so
minus 27.
see here charge to mass ratio is 1.75 into 10 power 11 coulomb per kg. Okay, and here what is the charge we got? Minus 1 point, like that now. So mass can be written as Q by M ratio. That's it now. See, Q by charge by Q by M. So what we can remove this, we will be remaining with mass. So that is nothing but charge is 1.602 into 10 power minus 19 coulomb. See, just consider magnitude here. Okay, no sign here. Okay, and charge to mass ratio is how much? 1.75 into 10 power 11 coulomb. Okay,
Per kg.
Coulomb per kg. So coulomb removed. So you are getting your answer in terms of kgs. So the value here you got is 9.1 into 11 into 10 power minus 31 kg. Minus 31 kg. This is the mass of one electron. So you got three values. What are those? One is charge to mass ratio of electron, and the other one is charge of one electron, and you got one more is mass of electron. Three values you should remember first. Okay, then next. So next we have discovery of protons. Okay, so similar to the previous case, cathode rays we discussed now. So here it is anode rays. Anode rays means in the case of cathode rays, particles are like electrons are coming from cathode to moving to anode. So in case of anode, reverse, yeah, so moves from anode to cathode. Now again I am taking same tube experiment you take, so again I am taking gas G. So now what happens to gas G? When we ionize this, we are going to get G plus and electrons. Now tell me which particles move towards cathode and which particles move towards anode. Cathode attracts cation, it means it should be negative charge. Here the tube contains positive charge, means attracts anions. Okay, so now which particles will move towards cathode, which particles move towards anode? G plus move towards cathode and electrons moves towards anode. Okay, so we are discussing about anode ray tube experiment. So here particles, these G plus are moving from this anode to cathode side. Okay, so now I am taking different gases. Tell me, I am taking H2 gas, I am taking O2 gas and N2 gas. So in this case the G plus ions will be different. What is this here? Let us say H plus and here O plus and here N plus, something like this we are going to get right now. So now depending upon the gas you are taking in the tube, the property of gas particles are varying. Okay, but in case of cathode rays all particles are having same nature, but in case of anode rays it is varying with the gas you are taking in the tube. Okay, so now can I call all the gas particles as protons? No, you should not call. So only when you take hydrogen gas you are getting H plus now. So H plus ions are called protons, whereas other gases, if you take ozone like oxygen gas, what is a gas particle you should call? Oxygen cation. If you take nitrogen, it should be nitrogen cation, like that. So depending upon the type of gas you are taking, the anode rays characters are changing. Okay, so anode rays are, can I say all the anode rays are protons? No. So anode rays are considered to be protons when we are taking hydrogen gas. In all other remaining cases it is just a gaseous cations. Gaseous cation. If I take oxygen gas you should say oxygen cation. If I take nitrogen gas you should say nitrogen cation. Okay, you should not say as a protons all the times when I say anode rays. Okay, but in case of cathode rays it is always made up of beam of electrons, but in case of anode rays not the beam of protons. It depends upon type of gas you are taking in the tube. Okay, is that clear? Okay. Okay, so this is also called as canal rays. Okay, now this important properties same to that, it is having a, these particles also travels in straight line motion, and what is the charge carrying by them? Positive charge, and they are made up of material particles. Similar to that, if you put a pedal here, they will rotate that pedal, same story here also. And mass of constituting particles depends upon the gas you are taking in the tube. Okay, so depends upon the nature of gas you are taking in the tube. Okay, so charge to mass ratio, see in the case of cathode rays, what you told, charge to mass ratio how much you got? 1.7 into 10 power 11 coulomb per kg you got. Okay, but here charge to mass ratio will varies. Why it varies? Because mass depends upon type of gas you are taking in the tube, right? Okay, so you do not have anode rays do not have fixed charge to mass ratio here. Can I say like that? Yes. Okay, their behavior in the electric and magnetic fields are quite opposite to the observed in the case of electron. So now tell me, what is the lightest positive charged particle we can get from this experiment? Hydrogen gas or hydrogen cation, that is what? The proton. So the hydrogen, the lightest positive charge particle obtained in this experiment is called H plus. We are considering it as proton. So why exactly proton we are saying? Because if you take hydrogen, what are the particles we have? Hydrogen atom I am saying. So hydrogen atom contains one electron and one proton. Do we have any neutrons in it? No. If you take any other gases like oxygen or any other gas you take, you are going to have electrons, protons and neutrons. So from this, if you get any particles, you are saying cations, like respect to cations here. But in this case, if you remove electron from here, so you have H plus. So what is a particle in this H plus now? Does it have electron? It is losing the electron and becoming H plus. Now it has only one proton. So it means only positively charged particle is there. So this is a source of the house of proton. So we can we call this as a proton? Yes, H plus ion is a proton here. Okay. So remaining ions are not protons, they are just gaseous cations. Remember that. Okay. So here also similar to the previous explanation, the charge of one proton is how much? Same, 1.602 into 10 power minus 19 coulombs. Okay. So for electron you put negative charge, for proton you put positive charge, and charge to mass ratio of proton is considered as how much? 9.5 into 10 power 4. These tables whatever I highlighted that are important here, that's it. Okay. And mass of a proton is how much? 1.67 into 10 power minus 27 kg. So now tell me, which is having more mass, electron or proton?
Proton is slightly more.
Not slightly, heavily more only. So how many times? See, it is just 1.67 into 10 power minus 27, that is minus 31. See how much difference it has?
4.
Yeah, 10 power 4 times almost. Okay, I will give you the exact relation, just hold for like few minutes. Okay, so now next one we have is neutron discovery. So this is by Chadwick by a nuclear reaction. See, he taken beryllium atom, okay, beryllium it is. So he just bombarded with a helium particle. So this is called helium particle, nuclear reaction it is. So now what we are going to get? See, 4 plus 2 is how much?
6.
So it contains 6 particles. Now we got a new particles here having 6. Okay, and add this 13. See, we got 12. So carbon 12 we got, and one mass number is missing. So this side you are saying 13, here it is only 12. So one mass unit is missing now. So that is for the new particle called neutron here. So what is the charge of neutron here? 0 here, 0. And this number indicates mass. Okay. So this is the discovery. The reaction is important here, remember. Okay. Next. Again, mass of this one is almost equals to the mass of proton. Mass of neutron is almost equals to mass of proton, but slightly greater. So I can say mass of neutron greater than mass of proton greater than mass of electron. Okay, these are almost equal like this. Okay, yeah. So now let us do one question. First, let us conclude what we have discussed. Who is the discoverer of this electron? J.J. Thomson. Okay, what is the charge we got? So minus 6.02 into 10 power minus 19. Now, this complete value let us consider it as 1 unit. Okay, and 1 unit I am saying. What is the charge here? We have sign minus. So I am writing it as minus 1. Okay, I am saying it as relative charge. And what is the mass of electron we got? 1 into 10 power minus 31 kg. Okay, similar to that, proton has discovered by Goldstein. Okay, so same value with a positive sign. Okay, so relative charge I can say plus 1. Okay, if this is minus 1, this should be plus 1. And this is a mass value I have given. Okay, and neutron is having this. Now just tell me this answer. Arrange the particles. Arrange electron. Arrange charge to mass ratio of electron, proton, neutron in increasing order. So which is like Q by M ratios of these particles, just arrange them in the increasing order, that's it. So what is your answer? Once again, see, I have applied mod here, so consider only positive values. So now tell me. So first for electron you tell me, what is the charge to mass ratio I can take?
1.75.
So in order to just to make simplify, I can use relative charges. Okay, what is the charge we have? -1. We have mod now, so I can take 1. Okay, what is the mass? Which is having mass of electron is, what I told you, mass of electron is smaller than mass of proton and mass of neutron. Okay, like this I have given. So which is having minimum mass? So minimum mass here now, and if you want exact value, you just take mass of proton is equals to around 1837 times mass of electron. So mass of proton how many times bigger? 1837 times of mass of electron. Next, mass of neutron will be 1840 times of mass of electron. So which is bigger finally? Neutron mass is higher. Okay, so now I can take mass of electron I am considering as 1 unit, then 1 by 1 will get, and mass of charge to mass ratio of proton will be how many times, tell me? Charge is +1 and mass is how many times with respect to electron? 18. So I can write here 1837. Right now mass of electron. Okay, here mass of electron, and charge to mass ratio of neutron is 1 by 0 by 1840 times of mass of electron. Now arrange. Now tell me which is having bigger value here. See, this is 1 by mass of electron. This is 1 by mass of electron into 1837. So out of these two, which is smaller value, which is bigger value?
Proton is smaller.
Electron mass ratio is bigger one right now. So Q by M of electron is greater, and between these two and between these two, so 0 by something will be 0 here. So and it is having some decimal number. So relatively mass of proton is bigger now than mass of neutron, charge to mass ratio of proton. So proton, and here neutron. This will be the order. Okay, if I want to add one more particle here, so just arrange that alpha particles in this equation. What is alpha particle? I have told you
Ionized helium.
helium +2 with atomic number 2, mass number 4. Yes. So tell me for that.
EPHEN.
So Q by N of alpha particle will be, what is the charge you are seeing on it?
2.
So 2 you can take, and what is the mass number you are seeing? 4. Why it is 4? Because it has 2 protons and 2 neutrons. Okay, so 2 into, I can say 1837 plus 2 into 1840 I can say. So now tell me where is the position of this alpha particle in the order?
Between
Proton and neutron. So it will be electron, proton, alpha and neutron. Okay, like this. You can arrange like this. Is this clear or not? Okay. Next we have atomic model. So we got 3 particles and their charges and their masses. Now we have how these particles were arranged in the atom. Okay, so now what he considered, J.J. Thomson considered, so atom as a
whole positive,
like having spreading around, uniformly spreading positive charge, like a watermelon you consider that plum is there now, red color part, as a positively charged species, like complete plum is positive charge, uniformly distributed, in which that seeds are there now, electrons embedded in that plum like watermelon. Okay, so means this electrons is nothing but seeds of watermelon, and this this blue color part is nothing but positive charge spreading around all over the atom, and overall atom is a neutral. Okay, in order to make electrically neutral, atoms like electrons are embedded in it with the same number of electrons as protons. Okay, so overall atom is neutral. Okay, so this is what the Thomson atomic model says, but later it got failed. When Rutherford came, it got failed. Why it got failed? Because what he told, the atom, throughout the atom, what he is saying, the positive charge is spreaded, like distributed right now. So but later on what he did is, Rutherford came with alpha scattering experiment. What is alpha particle having? The charge of alpha particle is +2 we told. Okay, so that is not what this is what the drawback. What is the drawback? See here. So when he take an alpha particle, okay, so now if we have an atom here, so atom is containing what? The positive charges. He considered that positive charges spread throughout the atom, he is saying. If this is a alpha particle having positive charge, if this particle is passing through this atom, what happens? Alpha particle should deflect completely. But what reality is, see, when he taken a gold foil here, this is a gold foil which you are seeing. See, this is the source of alpha particles. It means from this what we are getting? Alpha particles you are getting. So these alpha particles, if you observe, see how the lines are coming here. So they came out without any deflection. But very few particles, very few alpha particles having some deflection with some angles. Yes or no? It means alpha particle in in the atom, the positive charge is not uniformly distributed, but it is concentrated at a certain point. So in that point, whenever these alpha particles are going, the deflection is observed. But in the remaining positions, either hollow space or having some electrons. Because if positive charge is uniformly spread, what happens between alpha particle and that positive charge?
Attraction.
There should be repulsion and deflection has to be observed. But is it the same case here? No. Only in the small region where that nucleus, it means that whatever the positive charge is concentrated is considered as nucleus. In that position only some deflections are observed. In other remaining regions, no deflection, alpha particles coming out without any deflection. See, undeflected beams are seems like this. Okay, but very small particles having some deflection either with small angles or with large angles, and very like 1 in 20,000 particles were observed that they are going back exactly in their original path. It means the alpha particle hitting exact center point of nucleus, therefore the repulsions will be more because nucleus contain positive charge and alpha particle also positive charge. So that's why it is retracing its original path. Okay, this is what the scenario here. So therefore what I can say, Thomson's atomic model is failed here. Why it is failed? He is told that positive charge is uniformly spread, but is it the case? No. Okay, right. Okay, so what he observed, most of the alpha particles like 99% are passing through it without any deviation. Okay, but some of the alpha particles were deflected with small angles. Okay, and very few alpha particles are deflecting with 180, like retracing its original path. These are the points you should remember here. Okay, and what he told is, if we consider the nucleus as a cricket ball, so the size of atom seems to be the 5 kilometers around this cricket ball. See, the radius of atom would be how much?
5 kilometers.
If this is the nucleus of an atom having size of cricket ball, so the radius of that atom will be
5 kilometers.
so like that. You just imagine how big is it. Okay. And now what are the drawbacks of Rutherford? You should know. See what he told. Now the center part of the atom is concentrated with a positive charge considered as nucleus. Okay, around which he is saying, around which electrons are revolving, he is saying. So electrons are having what charge? Negative, and nucleus is positive. If this is the scenario, we know if two opposite charges are placed together, what happens? They will attract. It means if this electron is present here, that should slowly attracted by this nucleus and falls into the nucleus. It means atom should get destroyed. But is it happening? Atoms are existing, and we are existing means atoms are existing. But he was unable to explain why electron is not falling into its nucleus, why atoms are not getting destroyed.
Could not explain stability.
He was not able to or unable to explain the stability of atom. Okay, this is the main drawback. And he was also unable to explain spectrum, hydrogen spectrum of atom in case of hydrogen atom or any other atoms. Okay, that were again developed further by Bohr's atomic model, which is very important. We will study that. Okay, and now what are the terms we should know before going to the structure, like complete chapter here. First, what do we mean by atomic number? That is nothing but the number of protons present in a like that, number of protons present in the nucleus, and this is also equals to number of electrons in the case of atom. Okay, but in the case of ions, electrons participate in ionization. For example, A is an atom having protons 10, okay, and electrons are also 10, but if it is getting ionized like A plus 2, what about its electron count? 8. So electron count may be changed, but proton count will be remains same. So that's why we are taking atomic number is equals to number of protons. Okay, next, mass number means it is the sum of protons plus neutrons. So number of protons plus number of neutrons. Okay, so together considering it as nucleon, number of protons plus number of neutrons as nucleon. Okay. Okay, so if this is an atom, okay, element, okay, here you should indicate mass number, and here you should indicate atomic number, and here you should indicate charge, and here you should indicate atomicity. For example, O2 you are writing. See, what is the atomicity of oxygen here? 2. Atomicity is 2. Okay, and if I write F minus, what is the charge here? Negative. So charge here we are indicating. So chi indicates symbol of an element, where A indicates mass. For example, carbon 12, 6 we are writing. So 12 indicates mass and 6 indicates atomic number. And is there any charge? 0 charge. So it will be 0. And what is the atomicity here? 1. That's it. Okay, this is the standard representation. Now let us move forward with these things. Yeah. So isotopes, isobars, isotones, and isoelectronic species. So isotopes means what? Same atomic number but different mass number. For example, carbon has
2 isotopes.
Atomic number 6. Okay, so now with 6 atomic number, I can put mass number as 12, 13, 14. So these are the 3 species. If we extract carbon from earth crust, we are going to get the mixture of these things, C12, C13, C14, with a different percentage of abundances. Okay, so might be the after extraction you might be getting this as around 99%. So this is around some 0.01% like that, and this is very minute. Okay, yeah, these are rough values here I am giving. So now what is the difference between these 3 particles? Proton number is same as a 6, but number of neutrons
Are
different. So here how many neutrons are there?
12.
See, mass number means what I told you, it is sum of protons plus neutrons. What is the mass number here? You have 12, and protons are 6. Then neutrons will be 6 in this case. So here neutrons are 6, here it is 7, and here it is 8. Okay, here it is 8. So different mass number is because of different number of neutrons. Okay, so due to the difference in number of neutrons, now they will get different properties also. Like for example, sometimes some isotopes are non-radioactive, and whereas some other isotopes are radioactive. Okay, yeah.
C14 is radioactive.
Yeah. And we have now hydrogen having 3 isotopes. What are those?
Protium,
Like H11, H12,
H13.
H13. Okay, so this is called protium. It means normal hydrogen which we are discussing. Okay, we are indicating with hydrogen, and this is indicated with D, and this is T, and here T is there. This tritium is radioactive. Remain these 2 are not. Okay, which is radioactive here? Tritium. Okay, yeah. Next, what about isobars?
Different atomic numbers but same mass.
See, mass number has to be same. A value is same here. So argon, potassium, if you see, atomic numbers are differ, but mass number is same.
Potassium mass number is 39.
No, it is 40 only. Okay, next. Isotones means tone. Neutrons. Iso means same number of neutrons. Species having same number of neutrons. Okay, so atoms of different elements which contain same number of neutrons. Okay, so here you can check what is the difference. Here you get 36 minus 16. So you got 20 neutrons. Okay, and chlorine also 37 minus 20 again. 17 again, it will give 20. So same number of neutrons means isotones. Okay, so they will give which are the following are isotopes, isotones, like this. Next, isoelectronic species means
Same number of electrons.
so for example, O minus 2, how many are there?
10.
Oxygen atomic number is 8. Minus 2 means add 2 more electrons, so it becomes 10 electrons. F atomic number is 9. Minus 1 means
Add 1
so 10. See, 11 minus 1, because plus 1 means remove 1 electron. So all these are having same number of electrons, so we can say them as isoelectronic species. Now what type of questions you can expect here? They will ask you to arrange based on the size of this isoelectronic species. Arrange the order, size order of this isoelectronic species. I want from aluminium to oxide ion, this size. Tell me, which is having smaller and which is having bigger.
Aluminium 3.
So just remember, size will be inversely proportional to nuclear charge. So more positive charge, lower the size. So where do we have more positive charge? Al plus 3. So smaller size it is. Al plus 3,
Mg2 plus
Mg plus 2. Next,
Na plus
Na plus,
F minus O2 minus
O minus 2.
etc.
Like if I give nitrogen also, N minus 3 you can write like this. Okay. Next, when you consider a wave, it contains electromagnetic waves contains two components. One is electric component and another one is magnetic component, which are perpendicular to each other. Like this we have one, and another one is the electric component and magnetic component, which are perpendicular to each other, and they will propagate with the direction of perpendicular to their direction of propagation. Okay, yeah. So now what is, if I say a wave is there like this, okay, so what about this height? We can call amplitude, or this depth also amplitude. So now one cycle is considered like, this is a complete cycle right now, so this is a complete wave. Okay, so complete wave we can indicate with symbol lambda, wavelength we are saying. So if I draw only up to here, you can say half lambda by 2, or if I cut up to here
1 by 4
lambda by 4 you can say, yeah. Okay, so then now what are the terms here you should know here. So amplitude means just we discussed height of the crust or depth of a trough. Okay, the next frequency means number of waves passing through a point in 1 second. See for example, if wavelength is more, see I am writing,
frequency will be less.
I am writing a wave with this much bigger, and I am writing with this much. Now tell me which like wavelengths are different here. See, this is having this much bigger and this is smaller. Okay, so now number of waves travel from a point in 1 second will be more in which case?
Down.
Second case. So what I can say, frequency is inversely proportional to wavelength. Okay, is bigger the length of a wave, smaller the frequency. Okay, you can understand like this. Yeah. So yeah, so if I remove this proportionality, it will be c by lambda, the speed of light by wavelength. Okay, so just see here, the time taken by a wave to complete one vibration. One vibration means one cycle. Okay, the time required to complete one vibration is called its time period. Like one cycle to complete, how much time it is required. Okay, now if you take this complete spectrum, so we have different ranges here. So which is having higher energy here? Gamma rays, X-rays, UV, visible, IR, micro, radio, we have. So in this, which is having higher energy? Gamma rays is having higher. So from here to here if we go, energy decreases. Here higher energy, lower energy. Or you can say frequency decreases. Or I can say wavelength increases. Okay. So now here you have visible range now. So what is the range of visible spectrum? 400 to 500 nanometer. 750.
4,000 to 8,000 Armstrong.
You can consider in that units also. Okay. So now they will ask what is the order of energy, decreasing or increasing order of energies of this line, like spectrum. So you can write gamma, X-rays, UV, visible,
infrared,
IR, micro,
radio.
radio. Okay, this is a basic question. Okay, and what about this visible range, like VIBGR colors, which is having higher frequency? Violet. Or higher wavelength? Red. So that's why for signal purpose what they will use? Because of
no deflection.
Yeah, so better visibility we have,
Red.
longer wavelength for red, so that will be used for indicating any danger signals or like that. Okay, so tell me these basic questions from MSET papers here I have. The maximum radiation with maximum frequency is
X-ray.
which one?
X-ray.
X, just arrange them higher to lower.
X-rays,
Frequency.
ultraviolet rays,
X,
UV,
UV,
IR,
IR and radio. So you can answer with the first question, first one option. Okay. Next one, an element in +2 oxidation state has 24 electrons. What is the atomic number of the element and the number of unpaired electrons in it respectively are?
26 electrons. 26 electrons.
So element with, see an element in +2 oxidation state. Let us say X is an element, like otherwise A is an element having +2 oxidation state, has 24 electrons. In this +2 oxidation state, 24. If I want to make atom, so I need to add 2 electrons. So in atomic form it has how many electrons total? If I add 2, 26 total. Okay, so atom having atom having 26 electrons. So for an atom we can say atomic number equals to number of protons or number of electrons. So what is the atomic number? It has 26. Z equals to 26. Is this clear or not? +2 in the dipositive cation. In the atomic state it should be 26. Okay. Now what is the element with atomic number 26? Iron. Okay. Fe. Okay, 26. Okay. So what is the electronic configuration you can write? Argon 18. Next 4s2 you can write 3d6 26 now. So just remember 4s2d6 you put. Okay. So how many valency electrons or number of unpaired electrons? How many are there unpaired electrons? S orbital 2 electrons are paired. In D orbital 1, 2, 3, 4, 5, 6th electron. So 4 unpaired and atomic number 26. Okay. What about these questions? In two elements, like this, just now we discussed the following relation, M1 not equals to M2. Okay, the elements M is atomic mass, Z is atomic number. So just try to answer this.
Number of neutron isotones.
So what they are saying,
Isotonic. A answer.
m means mass number minus, so this is nothing but gives neutrons, right now. So m minus z is what? Mass number, like a minus z I discussed. So mass number equals to mass number m equals to z plus n, right now, protons plus neutrons. Now z minus m is n, so that number is same, means what? Isotonic. Okay, next, tell me for this, the correct set of species having isoelectronic species, tell me. Same.
C.
Isoelectronic species, just count number of electrons should be same. So this we discussed, like 10 electrons, 10 electrons, 10 on the case, and in this case these are having 10 electrons, O2 means 16 electrons and Ca plus 2 means 18. So C is correct only. Check any other option? No. Okay. Yeah, let me just. Okay, we'll start photoelectric effect in the next class, black body radiation, these things in the next class. Okay. So
Sir, physics class లేదా?
మేబీ లేకపోవచ్చు ఈరోజు.